There are a number of inferential statistics techniques which can be used to analyze the data, and these include correlation technique, significance of differences between means, and so on. As far as correlations are concerned, one can use Spearman rank order correlation, point biserial correlation, biserial correlation, multiple correlations, chi-square, or regression coefficient. Now let's examine when to use a particular technique for determining the correlation. Spearman rank order correlation is used when both variables are on ordinal scale. Now when I say ordinal scale, say for example you have a set of sample which has been ranked on the basis of their height, and you have also ranked them on the basis of their performance. So you can establish the relationship between height and the performance by calculating a Spearman rank order correlation, and it only indicates the magnitude of relationship between the two variables. Point biserial correlation needs to be calculated when one variable is on interval scale and other variable is a true dichotomy. Say for example, you are getting male and female and you are having their scores on aptitude test, and you want to establish the relationship between gender and the aptitude possessed. So you can apply point biserial correlation. Again, it is where you are interested in finding out the magnitude of relationship. Biserial correlation, on the other hand, is used when one variable is on interval scale and the other variable is an artificial dichotomy created by the researcher. Maybe you have a category which is pass or fail, or you categorize the sample into high, average, and low on the scale, or you have likes and dislikes for a particular phenomena. Chi-square is another frequently used technique where you would like to test the experimental hypothesis of independence. So if you are interested in finding out whether the performance of student is independent of their use of right or left hand, then chi-square can be used to test this hypothesis, and here the data is available in the frequencies. Thus, data is on a nominal scale where you have the left-handers and the right-handers, and you try to find out how many people have shown high performance who are with left hand and who are the right-handers, and so on. Regression coefficient is used to predict a phenomena. That means if you have a study where you have taken the joint entrance examination and you are interested in whether the performance in joint entrance examination can be used as a predictor of the performance in four-year degree program, then regression coefficients can be used. So here you have independent variable and the criterion variable, and criterion variable can be predicted on the basis of the independent variable. If you are interested in finding out significance of differences between means, and your objective of the study is to find out whether boys perform better than the girls on a mechanical aptitude test, maybe you are trying to compare the average performance of boys with the average performance of girls on the mechanical aptitude test. So you can use Z-test when the sample is greater than 30. That means you consider it a large sample and you test the hypothesis B1 is greater than or equal to B2, or B1 minus B2 is equal to 0. Or you test the hypothesis that B is equal to X in case of a single mean. And there are certain assumptions which the data set needs to fulfill, and these include that scores are normally distributed and there is homogeneity of variance between the sets, and the scores are available, the variable is continuous. T-test can be used when the sample is small, and again you are testing the hypothesis whether B1 is equal to B2 or B1 is greater than B2. The assumptions remain the same. That means you need to test the normality of distribution of scores, the homogeneity of variance, and the variable is continuous. And here, one or more independent variable and two or more dependent variables can be compared. So, t-test can be used in case of small samples. Z-test can be used in case of large samples. But if you are likely to compare means of more than two groups, then there is no need to go in for calculation of t's, where you will first find out the difference between mean 1 and 2, then mean 1 and 3, and then you are going to calculate mean 2 and 3. So to economize, there is a technique which is referred to as analysis of variance, which can be used, which will provide you F ratio, and if F is found to be significant, further T ratios need to be calculated to identify which of the two groups vary. So initially, if you are interested in finding out the significance of differences among means more than 2, that is 3, 4, 5, then you are going to use the analysis of variance, and you can test both null hypothesis and or alternate hypothesis. And ANOVA also have the similar assumptions which are made for applying the t-test on the score or z-test on the scores, that is the assumption of normality, homogeneity of variance, and the continuous variable. ANCOVA refers to analysis of covariance. If there exist initial differences among the groups on any one of the variables, then we cannot use analysis of variance. We need to take into account those differences, and thus analysis of covariance help the researcher to take cognizance of the initial differences on the variable, and then we try to adjust the post-test scores on the dependent variable. And it allows for the correlation between initial and final scores and effect the adjustment in final or terminal scores, which will allow for differences in some initial variable. So you can rule out the initial differences that exist on one of the independent variables. Wilcoxon-Mann-Whitney test can be used when data is available on ordinal scale, and it allows the researcher to test the hypothesis whether the two independent groups have been drawn from the same population or different. So assumptions which are taken into account include that scores are sampled from a distribution which is continuous, and it is an excellent alternative to the t-test. Cochran Q-test for K-related samples can be used to test the hypothesis whether three or more matched sets of frequencies or proportions differ significantly among themselves. And under the null hypothesis, the test assumes that variable under study have the same underlying continuous distribution, and it requires ordinal measurement of the variables. Kendall's coefficient of concordance can be used to represent the degree of association among k sets of rankings. Now, this can be used if you have three different judges who have judged the sample on some variable and have given independent ranking to the people. So you can find out the degree of association or degree of agreement among the three judges with respect to the ranking given to the different people. So these are some of the inferential statistical techniques which can be used, and for further analysis one can go for advanced techniques like factor analysis, multiple regressions, or path analysis or structural equation modeling.